Start, or we're
Yes,
going to
we
wait
will.
for a while? I think we just wait for a while first.
Okay, sure.
Okay. Together between Sasi and UTM. And as the director, I also hope to receive a lot of outbound students from Sasi to join us in the coming semesters, semester two in 2021, 2022. And this also be a good opportunity for our students to become the outbound student to visit Sasi Creative Architecture School beginning in next semester 2, 2021, 2022. So I hope that since there's a lot of UTM students here joining us, so please take a note and please actually refer to me and also to the academic office, because we will start to give opportunity to students to become an outbound student to visit Sasi and to be with Sasi Creative School for one semester in terms of exchange student and also exchange program, and also with a lot of exchange academic activities. So with that, I just like to say a very warm welcome to everyone, and may today's international webinar be a successful one. And to the speakers, Prof. Sam, who is also the head of department from Sasi Creative School, and also to Dr. Lim Yetwah, good luck and all the best for today's presentation. And may both universities get a benefit from both of your presentation today. So all the best and good luck for today's presentation. So with that, I would like to officiate today's event, and I pass it back to the moderator, Architect Shahida. Thank you so much.
Thank you so much, Dr. Alice, for the remarkable speech. So now, before proceeding any further, allow me to introduce our first speaker for this webinar session. Our first speaker is Prof. Sam Charles Devanan. He's a head of department who carries over 17 years of experience across diverse verticals in the AEC industry, with specialization in project management and information management, and also as an academician. He has been part of Sasi Creative School of Architecture, India since 2020. So without further ado, I would like to call Prof. Sam Charles Devanan to deliver his presentation on alternative real estate mechanism. Prof. Sam?
Yes, thanks much, Prof. Shahida.
Thank you.
And good afternoon to everyone who is here. And it's been a privilege to be a part of UTM. I'd like to thank personally from my CS's behalf, Prof. Alice, Prof. Adelaida, Prof. Shahida, who will be the moderator here, and also Professor Lim. It's a pleasure to meet you virtually this morning. We do hope, as Prof. Alice was saying, we can have very much more interaction, collaboration that we come all the way forward. All right, now let me share the screen. So I do hope see this.
Yes, please.
All right, fine. Now, few of us might wonder what alternative real estate mechanisms are. Now, as students of architecture or from civil engineering, we always have heard about real estate, we have heard about construction, we have heard about anything related to construction. But this particular terminology, real estate mechanism, or I would say alternative real estate sector, is something that's been happening new in momentum over the last, I would say, a decade. A lot of studies have taken place because very specifically commercial property homes, like say Jonestown Lazaling, CB Richards, Night Frank, ABMG, a lot of people. Now, the core idea began this particular this morning is to ensure we shed a bit of a light on how. More importantly, we'll be looking at some of the drivers that actually create demand. And moving forward, we'll try to widen the session of ways in which we have into mechanisms of investment to the next level. Fine. To start with, I would like to show this particular slide, which was proposed by Professor Arthur Siegel from Harvard School. He calls this the real estate diamond framework. As the name aptly suggests, we can see four corners, and each of the corners have got excellent parameters and factors. And there are people from architectural construction and industry, we all know very well how each of these factors are absolutely interrelated or correlated Now, even with an absence of one of these parameters, you can so surely say that the entire investment might go for a toss. So what Professor Arthur tries to argue here is the first thing that we need to actually look in terms of product, in terms of the realistic framework is the product itself. Now, when we talk about product, this is nothing but project itself. I mean, the structure above the ground, everything that is below the ground as well, and everything that we can actually physically see, experience, and moreover, we can explore a lot of because the moment we need investment, talk about how visually appealing it is, how quite friendly it is, and more importantly, how post opportunity. And one of the other important things that we the moment we get into a particular project or a project, we have to ensure that anything that might decrease value has to be looked at or has to be, for example, that is one of the reasons why we go for feasibility studies, detailed project report. The second factor that Professor Radha talks about is people. Construction industry is very much more unorganized, and we can see a lot of people just move from one to another. It's very difficult to deal with as and very importantly, when we talk about relationship with people, we are just not talking about the labors or the daily wage people. Predominantly, we have to talk about stakeholders. It could be planters, it could be factors, it could be consultants, it could be anyone for the matter. The way in which we keep our relationship with these people, better will become investment. Profiling, and I'm trying to do it. Let me just, sorry. It's actually at the peak. Is it better? No. All right. Thanks for advising. Now let me just hold my microphone something like this. I mean, yeah. Fine. The third factor, what we're trying to figure out here is the external environment. When we talk about external environment, it is predominantly about the risks. Because when we step into a construction project, we are not aware of any that might pop up. It's always better for every one of the stakeholders to check what the risks, how to foresee the risks, and more importantly, how to mitigate the risks. And the last one is capital markets. Now, the entire presentation is going to be on alternative realistic mechanism, and investment plays a very major role. And when we talk about capital markets, the fourth factor in real estate, these are nothing but channels through which capital can be put for profitable use. Now, there are two capital markets. One is debt, the other one is equity. Equity is nothing but the company-owned
Sam?
capital. Yes,
Sorry to
Prashaya.
interrupt. Can you please speak a little bit louder because your volume is sometimes somehow a bit too
Okay,
slow.
let me just.
Your
Is it
mic
fine now?
probably.
Is it better now?
The rest? Dr. Elias, can you hear Prof. Sam?
Yeah, I
Yeah,
can. Is it?
I think so. Yeah, now it's better. Yeah, now it's better.
All right, much better. Thank you. I just taken the microphone
Okay.
jack off. I just stick to
Yeah.
the laptop. That's fine. I'm so sorry. Fine. Now, when we talk about capital markets, it's predominantly debt, equity. Equity is nothing but when I want a company and I want to raise capital, still a problem, Prabhshaya? Um, can you just give me a second? I'll just change the microphone. Is it fine?
Sure, no problem.
Yeah, sure, no problem. Architecture, maybe would you like to remind the audience who attending today's session? I think we have about 100 participants who just joined in regarding the ESET and also the attendance for today.
Okay,
event.
right. For those who just joined this webinar session, please take note to be with us and stay with us until end of this webinar session because towards the end later on we will be posting out the attendance form where you need to fill in, and after that you will receive a e-certificate for attending this webinar session. Okay, so make sure when you fill in the form later, make sure please write down or fill in your name, your full name in capital letter, and also please ensure to put in a correct email address because if you put in the wrong email address, might be the e-cert will not reach you. Okay. All right, Prof. Sam, are you ready to continue the session? Still sorting out the mic, I think. Okay.
I think
If
from
you have,
the yeah, I think
yes,
Architecture from the audience, we also have students from India, if not mistaken, here from out of the
yeah,
105 participants. Um, maybe you can just raise up your hand once.
Profile, just give me a minute.
Yeah,
I'm joining in from another system. Just a second, if you don't mind.
yeah, okay, no worries,
okay,
no
okay.
worries.
Don't worry, Prof. Sam. You will be here waiting. Not to worry that much. Yeah. Maybe anyone from Sasi can raise up your hand by clicking the reaction button down there, where there's a button with smile and plus, and you can raise a hand so that we can see who is from other schools and so on. I couldn't find any. At least, did you find any?
Profile, is it
Uh,
fine now?
Yeah, I think it's much clearer now.
Oh, thanks. All right.
yep.
Uh, Fine. Now, we just go back.
Oh, we're losing Prof. Sam now.
From Sam, I have.
Can you hear me?
Yeah,
Okay.
now can hear you.
When we talk about capital markets, it's more about debt and equity. Debt is nothing but the borrowed capital from banks, from financial institutions, whereas equity is nothing but where we raise capital from our own companies. I can have stocks, which I can sell it across, and then I can raise capital and I can use it on my projects. So depending upon the framework that the company actually has, we have to decide on the way in which the capital market has to be taken. Now, all these four factors, still having a problem? Professor, still having a problem?
No, no, yeah, everything is okay. So
Okay,
far, we can
perfect.
hear you.
Great. So with a little bit of this add-on in, I will move on. So we will, every one of us have got some clarity about what real estate is all about. Now, when we talk about real estate, one of the most important things that we actually figure out is there's something called the compound annual, nothing but CAGR. When we have a comparison of CAGR between a conventional real estate and alternative real estate, there are a huge difference. For example, if you look at some of the major real estate typologies like housing, retail, hospitals, commercial, the expected CAGR is around 30%. And out of the three typologies, commercial is the most strongest, which can hit a CAGR of around 20% and more. And if you look into the various investors who have been putting in the money with specifically commercial real estate, Bangalore holds the maximum. Even 19.4% of investors are putting in the money in Bangalore commercial real estate, followed by Ahmedabad. When we talk about hotels, they've got a CAGR of 13%, and if you look into retail, we have a CAGR of around 11.2%. Having looked into all this data and the numbers, one thing that we understand is how much of pressure we're actually putting. The more pressure we're putting into something, the more pressure we're putting in terms of the natural resource. The second thing is looking at this four options like retail or housing or hospital or commercial. The moment we are done with the project, we have to start giving it terms of that it so that we
get it
get the revenue as quick as possible. But
get the revenue as quick as possible. But if you're
Prof. Sam, somehow the other device,
yeah.
you can hear clearly your mic.
I'm just wondering. 1 second, please.
Just to double check with you, you are turning on two camera, is it? Using two device? Okay.
Is it fine?
Okay, this one. Okay, so can we remain with this one?
I guess I'm so sorry. All right.
No problem.
All these four typologies, it actually needs to generate the revenue the moment we are done with it, whereas we can't expect the same to happen because what happens is, Prof. Shahid, I mean, is it fine or is it still a problem?
So far, so good. It's clear now.
All right. Thanks much. So when we look into this real estate property, I mean, when we look into the various stakeholders who are there in this project, we have to ensure that we give as much of returns to them as possible. And when we talk about returns and we talk about a better CAGR, there comes our alternative real estate mechanism. Now, these sectors are nothing but the non-core asset class. Whatever we saw in real estate, they are actually the predominant way of doing things like housing and hospitality. These things are kind of predominant. Everyone does it. What we fail to understand or what we fail to actually achieve is how quickly the returns can actually be kind of recovered or received from the other end. And that is when this alternative real estate sector actually comes very handy. And these sectors can fall into different parameters like student housing or education, aged care center, data centers, and pretty much more. And one of the most compelling parameters here that actually puts a stop so far is we might not have a compelling data to have investment decision making that has literally hampered the way in which alternative real estate should have grown long back, but somehow it hasn't been happening. Now, a lot of people have started doing a lot of research and they're trying to find out ways and means to have compelling data, which will aid decision-making prowess as well. And if you remember, I was talking about CAGR of real estate, which can tune up from maybe 20 to 25%. But very fortunately, when we talk about the CAGR of alternative assets, it actually gives a consistent 28% of CAGR. When we talk about CAGR, it is nothing but the ratio between the end value and the beginning value and a percentage of it. Now, I'm not too sure about whether I can handle CAGR in detail because it's a little bit of a calculation. So I would like to better skip. And then if there is any question that can crop up a bit later, then I'll be happy to sort that one out. Fine. So one compelling reason why investors actually move forward from conventional real estate to alternative is that we saw CAGR, or the compound annual growth rate. Few other things that actually make them move into that is less volatility and less uncertainty. Let's say, take an example. I make a commercial property with maybe 1 million square foot, spending, let's say, $1 million, and I don't have any takers. What eventually will happen is because there is no demand, that leads to volatility because I cannot foresee what will happen. So whatever money I have invested, that $1 million becomes useless, and it just becomes something called the locked up capital. Less uncertainty. Whereas in alternate real estate mechanism or alternate real estate projects, they are kind of less volatile because these things are on a longer run. Maybe we may not get the returns straight away, but slowly and steadily we might get the returns. But more importantly and more efficiently, these returns are going to be dynamic, and more important, these returns are going to be as affirmative as possible. The second thing, why investors actually turn themselves into alternative real estate is these projects are less uncertain. Again, let's take a hotel complex. I'm going to be constructing something with, let's say, 150 keys. Unless I do a proper feasibility study, I might not be able to come to a conclusion about the number of keys that I will be having. But the moment I do a compelling feasibility study, then yes, I'll be having a very clear-cut picture about how many keys. But it doesn't mean that all the 150 keys will be filled, or I'll be having a consistent occupancy rate of 80% and above. There are a lot of ways in which uncertainty happens. Say, for example, the best example is the pandemic that we actually have been going through, where the entire hospitality industry got knocked down and the travel industry got knocked down. When these kind of uncertain situations happen, obviously the developers will suffer a lot of loss. And that actually forced them to get into diversification, where they put their money not on just one particular typology, but into a streamlined type of different typologies, which will eventually be giving them a very higher rate of interest as they move forward. And the third thing that they actually look into is they look for stable portfolios. If I do a school, I can be so sure that the school doesn't have an end, because as long as we are alive, the humanity is going to be in place, schools are going to be in place. So at any given point of time, I can gain interest out of it. Similar with data center, there is a lot of technology that has happened, and more importantly, there are a lot of companies that have come up as well. And every one of these people need technology to the core. And because they are not able to offer data centers on their own, they have to go for a hosted data centers as well. And these things actually put the real estate investors back on track to look for a very effective investment on alternative real estate. So I would like to just give a little bit of an insight from Rohit Hemnani. He is the head of alternatives capital markets at Jones Lang LaSalle Asia Pacific. He says investments in the alternative sector provides more direct access to the compelling demographics and demand drivers associated with the growing population while enhancing returns when talk about diversification. Now, diversification is one of the most important parameters that we need to actually think about. There is a saying by Warren Buffett of Berkshire Hathaway. He always says, don't put all your eggs in one basket, which means try not to invest every one of the penny in one particular, I would say, stock or a project. Because, say, for example, I have a lot of money, but I'm investing all the money in just the airline stock. And I'm not investing on anything else because I feel airlines give me pretty much more returns. But it would have been wiser for me if I had invested on rails or some other resources like gold or silver or platinum, whatever it is. Why we say this is, let's say, unfortunately, or as an unforeseen circumstance, if the airline pilots are going to be going for indefinite strike, then it is sure that I, as an investor, will be losing the entire chunk of money that I have invested in any one of the airlines. So it is always better to go in for diversification. And what we predominantly see here is when we talk about diversification, it is pretty much more about spreading your money, spreading your portfolio in such a way that you have streamlined return. And second thing is you have something very handy. And the third most important thing is you have something called returns. And that also will be based on risk adjusted returns. Because when we foresee risks, we actually think about mitigating those risks. And the reason why we mitigate those risks is to ensure that we get as sufficient returns as possible. Fine. So this is again taken from Jones Lang LaSalle. I would say they are one of the first to actually talk about alternative real estate. The slide that we see here it actually is a correlation between the key sectors and also the demand drivers. The demand drivers are age demographics. Now, every one of the countries, we have a certain bit of, certain kind of age demographic, and this actually defines the way in which the projects can be taken forward. Urbanization, we have been having unexpected sprawl over the last couple of decades or 3 decades, and it is unprecedented, and we don't even have a clue about what will happen in the future. Consumer markets, another very compelling thing. We have a rising HNIs or high net worth individuals who actually make things better for us, or sometimes they actually make it worse for us as well. Rising wealth and economic development, and the per capita income is slowly and steadily rising almost across all the developed nations as well as developing economies. And that actually puts us in a very brighter map to going for pretty much better projects. And finally, technology. Now, if you look into most of these drivers, they're all broader, and all these things have got lesser uncertainty. The reason is very simple. Every one of these drivers have been carefully studied, have been carefully analyzed, and have carefully been researched and put forth in terms of data and meaningful information. What JLL wanted to do was to do a little bit of a mapping between the drivers and the different types of alternative sectors. Now, when we talk about aged care, of course, we know anyone who is beyond 60 years can be considered elders. And the factors that actually are going to be playing with this key driver is going to be age demographics. So the countries which has got pretty much more elderly people, those are the places where we need pretty much more aged care homes. And it also depends on rising, because nowadays we got retirement plans, pension plans, and a lot of other plans which actually make the elderly people ready to live a life on their own once they hit 60 or plus. Technology is another thing. We somehow forget, to implement technology in hospitals, at least during the design part. But technology will play a very major role, very specifically in terms of aged care, in terms of using sensors, in terms of using a lot of automation systems. Everything is going to be making their life as safe and easy and smooth as possible. Student housing is the second type of the mechanism that we talk about. This actually depends on a lot of factors except for technology, because it again depends on how many children have been enrolled in schools or in education facilities. It's all about urbanization. It's all about people's influx into a particular city. It again depends on consumer markets, because a lot of expatriates are actually wanting to have the kids have schooling happening, wherever they stay and wherever they have the jobs. The similar thing is going to be applicable for every one of the other the typologies like data centers and renewables, as well as self-storage. Now, let's just go in detail about what these things actually mean. And one of the most important things that I would like to talk about is the drivers that actually drive the growth. Now, we were looking at 5 drivers, key drivers, which actually dynamically driving it forward. And every one of us know population explosion is the important factor that has happened and that has actually helped us in both negative and positive ways, very specifically in terms of real estate. Now, some of the information, some of the data that I would like to put here is about the population in APAC. And we expect it to hit around 400 million over the next decade. And more importantly, at least 30 to 40% of students are expected to get enrolled in education institutions. And then the second compelling driving factor is your unprecedented improvement in technology and advancements in technology. Now, China alone is expected to have an incremental growth up to $25 billion in terms of data centers. And there is also going to be more number of mobile phones that are going to be added every single day. And because of medical facilities, because of healthcare, and because of a lot of other factors, on one side, we have the younger population going up, as well as the elder population staying alive and healthy and hale even beyond 65. And all these factors give us a very compelling reason to ensure that yes, these alternative real estate mechanisms or sectors are, I would say, maybe a thriving proposition for the future of real estate and very specifically future of real estate investment. Taking this forward, a few other things which I would like to put forth is the availability of better financial data. Now, I was talking about few reports that were given by IPCs, and now there are better financial data that has been consistently available from these people, and they are highly supportive in terms of taking decisions at a quicker time frame. And the second most important thing is the structure of alternative real estate investment. Now, as I already said, it's a long-term proposition, which means you can wait for as much of time as possible before you can reap in the benefits. And sometimes in terms of aged care or in terms of renewables, it's going to be taking a lot of time. And sometimes it can even exceed 20s, but it is worth the wait because the more you wait, the income is going to be steady and balanced and seamless, which means you're going to be having a affirmative rate of return even after 20 years. And then your returns are going to be kind of stable and dynamic as such. The most important thing is the research, which compellingly says that any return from alternative real estate is going to be somewhere between 10 to 15%, which is a good number. And when we talk about the CAGR, we always talk about how much of money we are going to be putting it back onto this. Now, but talking about the compound annual growth rate, one assumption that we normally make is any profit that comes out of that particular investment will be reinvested at the end of each period. So the more profit that you're going to be gaining, the more effective you'll be able to reinvest, and the way in which you can. We'll be seeing few of the compelling factors which actually are leading the way as far as alternative real estate sector is concerned. The first and foremost thing is student housing. Now, these examples are taken very specifically for the APAC or Asia Pacific countries, and I haven't looked into the global trend. So please bear with me, and that's a disclaimer that I would like to actually make before I just continue. Student housing, there is over 20% of demand by university operated supply. Every one of us know students prefer campus or on-campus accommodation. And a lot of studies that are taken by the Human Resource Development Ministry and a lot of other people have consistently been saying this. But in the recent days, there has been, I would say, a paradigm shift in terms of students' ability or students' perception towards going in for some accommodation, which will give them a pretty much more, I would say, freedom, pretty much more facilities, amenities, and all those things. Though student housing is at a very nascent stage in India, few factors actually come into play. One is the increasing student population. As you can see from the slide, nearly 18% of the 1.3 billion are going to be aged between 15 and 24. And that is the age where they're going to be doing their schooling, their college, and their masters, and every one of those things. And the second thing, what we talk about is there's something called the PBSA, or the purpose-built student accommodation. And that has got a demand of around 8 million. And in the next 5 years, the demand is expected to be hitting around 10 million. And there is also a flow of international students. As Prof. Alice was talking about, we might expect outbound students from UTM to SCSA to have a semester exchange. And when these kind of things happen, if a particular campus is not flexible enough or is not in a position to accommodate those students, then obviously we go for this kind of student housing, which will give them pretty much more facilities and amenities. And the fourth important factor, which is pretty much compelling, is the GER, or the gross enrollment data. This is nothing but in the total number of students or the average number of students enrolled in an university every year. And very fortunately, between 2010 and 2018, this number increased from 19.4% to 25.8%. But because of technology, because of the national education policy, this ratio is expected to hit 50% by 2035. So by 2035, if you're going to be having a GER of 15, then obviously we can be sure that this 18% of population might get hit around 24 to 25%, which eventually be increasing the total number of PBSA that will be required. So that is one of the first ways in which we can look into the alternative real estate investment and mechanism. The second one is data centers. Every one of us know, because my experience in the past, I was with an information technology company, and our entire product was in data centers. So we had visited data centers, and we know how the redundant servers, backup servers, and every one of those things actually work. Those centers used to be expensive way back. I would say even 10 years back, it used to be costing billions of dollars. But now, because of outsourcing, it has come to drastically low. And very importantly, when we look into the numbers, um, the rise is going to be hitting around $3.5 billion in the next few years. And also every one of the companies that have been offering data center, either as a co-location or as a hyperscale one. Okay, now co-location is nothing but it's a kind of a rental one. If I want something, let's say if SAC has a data center, I can rent it to UTM or any one of the institutions. So that is what we call it as co-location. The other one is hyperscale. Hyperscale is nothing but big data analysis. Or big data companies like Apple or Google or IBM or Microsoft, anyone that uses. Now there is a huge difference between these two, and what we predominantly focus are the co-location data centers. And there are few I would say takers, and very specifically, if you look into India, there is someone called Control-S, CTRLS, and they are the only rated for data center. And when we talk about rated for, it is about their uptime is 99.995%, which means their downtime is closer to 0%. So that makes it pretty much more compelling. And more importantly, the better the ratings are, the more they will be able to scale up their data centers, and the more will be the investment on data center. And data center investment, they're expected to give a CAGR of around 21% in the next few years. And the third one is aged care. When we talk about aged care, we normally talk about elderly people. It's about orphanages. It's about so many other components as well. But very unfortunately, this is a sector where not much of importance has been given so far. Though we talk a lot of assisted living or skilled nursing or retirement living and this care and that care, but not much is happening. And that is one of the reasons. If you look into the investors, very specifically the first-time investors, they would like to predominantly invest on aged care centers because they know there is a huge gap between what is expected, what is given, and people try to make it as a kind of a money-making sector right now, which also gives them a steady flow of returns. Self-storage, and I'm not too sure of how many of us have heard about this before. During pandemic, most of the people lost jobs, which means they lost their income. And in many cases, people had their apartments or whatever it is, and they were not able to pay rents. But they also were having all the furniture, their upholstery, television, this, that, and all those appliances. So when they figured out where to keep all this furniture, because I was not able to pay rent, but I don't want to sell my furniture and all those things. Is there a way where I can store? And that came this particular business proposition called self-storage. So what it actually means is you will be given a little kind of kiosk or something. They also give you climate controlled environment. So if at all, you're dislocated or, if we get into a divorce or death or something, those properties can be taken onto those self-storage spaces. You can keep it there at a chargeable basis and you can retain it whenever you want. It is like using a bank locker facility for your jewels or some of your valuables. This is something that is actually growing. United States and China have been major players on this particular front, and we're also trying to, even India and some of the APAC countries like China, they are trying to actually improvise and they're trying to use the best out of it. As they actually figure this is going to be one of the killing segments as far as alternative real estate sector is concerned. Education is another one. this is something similar to what we talked in terms of student housing. The one thing that I would like to stress here is the expected tuition fee sometime in the next 15 years. They're expecting around $113 billion in terms of annual tuition fee, which translates into the total built-up area and which actually correlates to the IRR or the internal rate of return, which is calculated to be 10 to 15% and 35% for PropCo and OpCo. Now, PropCo is nothing but the property company, and OpCo is nothing but the operating company. Now, PropCo is the one which actually runs the business, and OpCo or the operating company is the one which actually generates revenue out of what is operated by PropCo. It's a big chain that actually happens, and all these alternative real estate sector or mechanisms are predominantly run by this SPV or special purpose vehicle, which is a combination of your property company as well as your operating company, and which is expected to give a CAGR of around 13.74% over the next 5 years. Few other things that we actually need to look into here is specifically in India. I'm not too sure about whether you have heard this. All major billionaires, like if you take Reliance Industries or Mahindra or Escort or Jindals, these guys have come into education foray. They have started building a lot of international schools, and of course, they charge exorbitant, but it actually is worth. The more schools we get to have, the more effective infrastructure is going to be. And as I said already, we have a lot of expatriates coming in over the next few years, and for those wards to have a better quality education, more number of schools are to be effectively open. And this is another sector where we can actually pump in our money. And the last one is renewables. Again, it's pretty much more about uh, um, a deviation from the conventional power supply. And we always know windmill or photovoltaic, there are a lot of other ways to do. And in fact, the Central Electricity Authority of India, they actually estimated that the renewable source is going to be pretty much higher in the next 10 to 15 years, because a lot of people have come up with the renewable power plant projects, and most of these guys are also having captive power plant projects. And specifically, when we talk about ITC or Indian Tobacco Corporation, they have a huge chain of luxury hotels, and every one of those hotels, they thrive on sustainability. They never buy power from the local electricity board, but rather they have their own way in which they have a power grid, and the entire grid is supported by renewable energy sources, and that is the way in which they actually operate the entire business. So, which means their tagline is responsible luxury, and they define it and they actually abide by what they say. Just last few slides, and based on the lot of studies, the research actually shows in all these 6 APAC countries, data centers and education are going to be a thriving business in almost every one of these countries, which are further followed by student housing and renewables and self-storage. Elderly care, it again depends. Very specifically, Japan will have elderly care because a lot of elderly people are there. India also is kind of grasping up, and the more number of projects are expected to happen in these sectors in the days to come. So going forward, we need to actually have a very deeper understanding about what we want and how we can going to be achieve this. And though alternative real estate is having a lesser market share around 10%, there is a compelling dynamic saying that there's going to be a lot more returns as we move along. And the best way to look into it is investing on something called REIT or Real Estate Investment Trust, which is again nothing but a company where you put in money, they actually invest in different properties, they get the revenue out of those properties, and they pay dividends to the investors. It's like stock market, but more. If the most important thing is most of these real estate investment trusts have their portfolios diversified, and most of them are in whatever we were talking: student housing, education, data centers, aged care, and also cable transmission lines. And that's it. I'm sorry. I mean, I think I took a lot of time more than precedented. Thanks so much, everyone. And if you have any questions, we're open for that.
All right. Thank you so much, Prof. Sam, for a very interesting presentation. on the real estate. Okay, if anyone has a question, you can write in the chat box, and then later we will answer it using the Q&A session at the end of this webinar. So now it's time for the second talk, okay, second presentation, and I would like to introduce Associate Professor Associate Professor Architect Dr. Lim Wah, where he is actually currently Deputy Director of Kalam Center for the Study of Built Environment in Malay World, and his areas of expertise are sustainable architecture, daylighting, building information modeling (BIM), and sustainability performance study. He has experience in conducting and leading several interdisciplinary research and consultancy projects in sustainable architecture and BIM. His research findings has been published in leading journals and also conferences in relevant fields. Without further ado, I would like to invite Associate Professor Architect Dr. Lim Wah to deliver his presentation with the title BIM for Green Building. On. All right. Okay, Dr. Lim.
Okay, thank you, Architect Shah, for the introduction. Can you hear me?
Yes, I can hear you.
All right, thank
All
you.
Okay.
Very good afternoon to all the participants, and also good morning to those who are from India. And thanks for joining this webinar. And just now, we have listened to a very wonderful lecture on this real estate investment, different mechanism in the future direction. The topic that I'm going to give is on this also related to the future. Okay. It's more on the technology and process in the building industry, but I will focus more on these green building developments. So the topic that I'm going to talk today is BIM for green building. For green buildings developments. For info, BIM stand for Building Information Modeling. Okay, we look at the world today, we know that we are facing different kind of issues, and the issue of global warming and climate change is like unprecedented. Okay, we can see the problem of the rise of the sea level and a lot of natural disaster, for example, the floods, flash floods, and different kind of catastrophe that's happening around the world due to the rise of this carbon emission and air pollution and so on. And if you look at the population growth and the energy demands in the world, if we refer back 50 years ago, we can see the world population was only about 2.5 billion. And today, up to 2020, our world population is up to 7.7 billion. And 50% of them are settled in the urban areas. So we can see that there's a exponentially growth in the world population and also urbanization, and it's expected up to 9.2 billion people in 2050, and 75% will be in the urban or semi-urban areas. And if you look at the energy demands, actually it's very correlated with this population growth. And if you look at the past 100 and past 50 years, it is an exponentially growth unprecedented in the world before this. So we are having I would say unforeseen future with a lot of unprecedented issues that might happen, that we as in the built environments and in this world that we are facing nowadays. And we know that the world is changing. 100 years ago, this is the phone that we have. Okay, maybe some of you have never seen this kind of phone before, or you only see it in the museum. And 50 years back, we have a very large mobile phone that we need to carry around. But today, we have this smartphone. It's more than just a phone, but actually it's integrated all different kind of technologies that you can connect to the world, okay, including getting all sources of information and social media and so on. And if you look at the car that today, 100 years ago, this is the car that we have. There's no aircon. It's slow. But after 100 years, we are moving forward to electric vehicle. And not only that, is also autonomous or self-driving car with the AI. So if you look at the world, the technology is also growing exponentially. Okay, if you look at this Moore's law, you can see that the number of transistors in the microchip double every 2 years. And some people already say that this Moore's law is no longer applicable, okay, because already exceeded the growth. And some people is also even talking the future is faster than we think because of the convergence of technology, and is transforming the business, the industry, and also our lives. For example, we can see that nowadays we have this 3D printed rocket engine prototype designed by artificial intelligence. Okay, this is a convergence of technology, including the computing, AI, artificial intelligence, and also 3D printing to come up with this product, okay, which is a rocket engine. In the past, rocket engine is something very advanced, so difficult to produce, but nowadays with the use of AI and is 3D printed. So we can see the power of convergence of technologies. Then how about the building technology today? If you look at the building 100 years ago, compared to about 80 years ago, is the building that we have. And now this is the city that we are living in. So we pose a big question here. Is the building industry behind on the technology changes? Okay, of course, we know there are some new building materials, some new building system and products coming out. But in overall, the workflow, the way of the building industry and the construction, the process is very much still the similar. Okay, so it's a big question that why the building industry is left behind compared to other industry in the world. And what is the impact of building environments on the climates? We are living in the cities. As you say, the urbanization rate is growing. Now it's 50%, but in future it will grow to 75% very soon. So what will be the impact to our mother nature? So if we look at the building industry, it's generate as much as 30% of construction waste. Can you imagine the resources that we pump into construction, 30% actually go to waste. And it's expected to reach 2.2 billion tons of waste annually worldwide by year 2025, another 4 years to go. And building sector consume about 36% of energy use and contribute to 39% of energy-related carbon dioxide emission globally. So we are contributing, the building industry is contributing to a huge amount. And even though there are different green building assessment has been established more than 50 years, 30, 40 years ago, okay, for example, Brim, LEED in US, okay, in Malaysia we have GBI, but building energy usage is still expected to surge by 50%, okay, by year 2050 if no further action is taken to mitigate this problem. So we have to do something. If we are still doing the same thing today, we expect by 2050 the energy used in the building will increase by 50%. So it's something very urgent and important for us who are in the building industry to look into this issue of sustainability. And we look at the building carbon emission throughout the life cycle of a building. 10 to 15% was during the construction phase, while 75 to 80% is during the operational and maintenance phase, while lastly 10 to 20% during the demolition phases. So we have to look at the building life cycle totally. We cannot just look into one aspect, but we have to look into the entire building life cycle and see how to reduce the carbon emission. And if you look at the demand of construction industry, especially in the developing countries like Malaysia or even India, is expected to grow. For example, in Malaysia, is expected to expand by 10.3% per annum. And we know that building or construction industry is strongly correlated with our economic developments. Okay, it's strongly correlate with our GDP per capita as well. And just now I talked about this construction waste. So a lot of time the waste happen during different phases of a project. For instance, during the planning stage, the info have to pass to another phase for design development, then pass to another phase during the construction stage. And during different phases, there are different parties involved, like the consultants, the contractor, the suppliers, and so on. And a lot of time there is lack of collaboration throughout this transitioning of the phases, and there's a poor information integration. So there is a fragmented nature of the construction industry that leads to construction waste, poor design, lack of integration, and poor building performances. So integrated design and the project delivery is very important for us to achieve a continuous information collection and to be more integrated in our project delivery. So from here, we can see that building industry is considered as one of the most inefficient and wasteful sectors, which give negative impacts to the environment. But however, it's very slow in adopting the technology innovations. Okay, despite the project complexity is getting higher and higher, and the demand of the sustainability is more urgent. So the development of building information modeling, or we call it BIM, BIM, has been recognized as a platform for sustainable and also integrated building design and project delivery. That's why today I want to talk about how to use BIM to achieve green buildings. What is BIM? Okay, of course, some people might relate BIM with some software. Okay, for example, Revit, ArchiCAD, Bentley, and so on. But actually, BIM is more than that. Okay, BIM is more than just a software application. BIM is more than just a process, and it's more than just a technology. It's actually is a combination of all these things. According to the definition by American Institute of Architects, it says that it's a model-based technology, okay, linked with database of project information. So the keyword here is model-based technology, okay? And this model covers geometry, spatial relationships, and geographical information. And it covers the quantity properties of building components. And according to Building Smarts, the definition is a digital representation of physical and functional characteristic of a facilities. So here mentioned is not only physical, but it's also the functional characteristic. That means we not only looking at the geometrical or physical things like the dimension, the properties, material, but we also look at how the building operate, perform the functional characteristic throughout the life cycle of the building. Start from the concept, schematic design, all the way until operational phase. So the use of BIM for integrated design is a project delivery paradigm shift from documentation-centric model, where each party actually communicate using 2D documents, drawings, and is a linear communication. But when we paradigm shift, move to this BIM-centric, we are actually information-centric model, where all the parties simultaneously and synchronize to share the same information platform with all the parties involved in the AEC industry. So we can see that it's very important for the project delivery and also the information to be passed on from one phase to another phase to avoid the waste of time, the waste of manpower, the waste of resources. And BIM is a platform that can support or facilitate this kind of collaboration. And we talk about integrated project delivery. If you look at this is a chart of the time frame against the effect of the impact. Okay, if you look at the first line, okay, if you look at the first line here, the blue color first line, okay, it's the ability to impact costs and the functional capabilities. That means during the early stage, during the pre-design, schematic design, all the decisions that we make have a great impact to the performance of the building, because that is the time where we decide how to orientate the building, the site planning, the form, and so on. So if we make wrong decision at the very beginning, then it will bring a very high impact, okay, to the consequences to the building delivery later on. But if you look at the second line, which is the red color line, second line, you can see that it's the cost of design changes. So if any changes during the earliest phases, actually is very minimum cost, or it could be zero cost because the design haven't finalized yet. But if we make the changes during the construction phase, the cost will be higher. And even worse, if during the operational phase, that means we need to renovate or refurbish the building. So there will be additional costs. So in the black color line, which is the line number 3, is the traditional design process. So in a conventional way, a lot of decision making was made during the construction documentation phase or during the construction phase. That means during the tender, when we're preparing all the tender documents, tender drawing, the spec, when we started this construction, then still a lot of changes because a lot of detail have been overlooked, and the changes will cause a lot of variation orders, and they will have great impact on the project cost. That's why the ideal or the preferred design process is to push this bell curve, okay, move it forward to the early stages in the schematic design and design developments, so that we can make most of the important design decision at the early stages to avoid any variation at the latest phase. Okay, and that will have a higher impact on the project outcome, the performance, while lesser impact on the additional costs. Okay, that's why BIM is very important for us to facilitate the design process from the beginning, and the information can be passed on from one phase to another phase throughout the life cycle of the project. So the benefits of BIM, it can produce a better outcomes through collaboration, enhance the performance, optimize solution, greater predictability, faster project delivery. Okay, because we can do clash detection, we can avoid the mistake or the discrepancies during the design phase. Then we can avoid a lot of reworks or hacking works and redo on the site. Then we can minimize the construction waste. And we can achieve faster delivery, which we save time. When we save time means we save the cost and resources as well. And we can reduce the safety risk, fits first time, the whole life asset management, and also continual improvements. We can use the BIM model to monitor the building performance to enhance it during the operational phase. And this is the different levels of adoption of BIM in the BIM maturity map. If you look at here, there's level 0, 1, 2, and 3. When we have done nothing about BIM, we are still using CAD, then we are in a level 0. But when we started doing using BIM to do some model, simple objects, and it's still very file-based collaboration, that is called level 1. Okay. But that is not yet the full potential of BIM. At the moment, actually, especially in Malaysia, our market is still very much at level 1, where we only use BIM to do some 3D model and produce drawings and some visualization. But when we move forward to level 2, where we have collaboration and library management, there's very different parties, different stakeholders in the project collaborate together using BIM. And when we move to iBIM, integrated BIM at the level 3, there's where the time all the information can be integrated to do different kind of application and assessment throughout the life cycle of the project. Then we can see the full implementation of BIM and the benefits of BIM could be achieved. And we look at this pyramid of BIM, okay, it's like an iceberg. A lot of time we only see the tip of the iceberg, okay, which is the building model itself. Okay, when we look at the top, we only see the model, structural, architectural, mechanical, MVP model. But actually below it is all the information contents, which are the schedules, classification, logistics, safety, and so on. And even further deeper is about data management. Okay, there's a lot of data that has been embedded into a single model. So a lot of time we only see the tip of the iceberg, but we have to acknowledge it's very important to have a proper data management, information management in order to achieve a good BIM modeling and also to achieve the BIM objectives. If we look at the application of BIM, there are 3D, 4D, 5D, all the way up to 7D. Yeah, some people even say there's 8D. So 3D, we are very familiar with that. Okay, we know it's about three-dimensional modeling. 4D is about the time. Okay, we can model the time scheduling or the phasing in a BIM model. We can model the sequence of the construction. We can model the logistic and so on. 5D is about cost. Okay, it's very important to have a cost planning. We can extract the data from the material takeoff in order to calculate the cost estimation. And 6D is about sustainability, where we evaluate the building, the facility throughout the life cycle, the operational, energy consumption, and so on. Okay, and it can be used also to evaluate for green building certification, for example, LEED or BREEAM or GBI. And 7D is about facility management. We talk about the as-built BIM, the life cycle strategy and maintenance, and even until refurbishment. Okay, I have introduced the level of maturity, okay, which is level 1, 2, 3. And I also introduced about the different application of BIM, which is 3D, 4D, 5D, 6D. And now I want to talk about level of development, which is LOD. Okay, what is LOD? Okay, in the past was called level of detail, but currently is renamed as level of development, because it's not only about the detail, but it's about the phases, the development phases. Okay. When we say LOD 100, that means it's at the conceptual design. Well, 200 is the schematic design with approximate geometry. 300 is developed design with precise geometry. And then 400 is construction and fabrication. But people start to insert 350, which is in between. That's for tender and coordination. Okay, and 500 is as-built. And some, they also define 600, okay, during the facility management. And this is an illustration, okay, for different level of developments in the BIM model. For example, in LD 100, a door is just a concept. No? It is just indicate that there is a door there. But you never mention what is the size of the door, how to swing the door, okay, what is the material of the door, still do not know. It's still at the conceptual design stage. So when we are doing conceptual design, actually we do not need to detail up all the information, otherwise it's never ending. Okay, so we move on to prelim or schematic design. Then we start to put in the approximate dimension, and we move to detailed design. Then we put in the material, the finishes, and some of the specification. Okay, when we move to LD 400, that means the construction phase. Then we need to be very detailed to say who are the supplier, manufacturer, what model is that, and what is the cost. Okay, in the as-built, we even know that when was it being installed, and during the operational phase, LD 600, we even monitor it if the door has been repaired, replaced with another brand or another product. Okay, that is how we can use a BIM to monitor the life cycle of a building and to evaluate the environmental or sustainability of the building. Okay, if you look at BIM LOD, level of development, and the integrated design process. In the traditional design process, remember the curve that I showed to you? A lot of decision was made during the tender and the construction phase, where we need to do a lot of spec and detailed drawings. But all these changes will have high impact on cost, but low impact on the building performance. Okay, so we want to move forward the design decision making at the early phases during the pre-design, conceptualization, and schematic design and design developments. That's how we can map with this LD 100, 200, 300. 250, 400 during construction, and 500 during the operational phase. And we want to achieve a lot of decision making, design decision making for optimized solution during the Bim LD 200 and 300. Okay, so the information is very important to pass on from one phase to another phase and synchronize with all parties so that we can make informed decision making during the project delivery. And we relate this design process with the green building design, okay, and also the Bim LV. So we can see during the conceptual design phase, which is the LD 100, is an illustration, okay, it's a concept, okay, it's just a form, massing, there's no detail. So what are the design variables or consideration, and also what are the performances that can be evaluated during that time in terms of green building performance? For instance, at the conceptual design, we can look into the conceptual form, massing, orientation. It's very important because once our fix our orientation, it will have a high impact on the solar heat gain, daylighting, ventilation, and so on. So at this stage, we have to make an informed design decision making. Okay, and we also can model the site context where we include the surrounding buildings, adjacent buildings. We can model it, and what are the performances that we can simulate or evaluate. For example, the site analysis, solar study, the macro wind flow. When we have the site context, we can evaluate how is the wind flow. The building form optimization, how we can orientate the building. Do we want to slant our facade, okay, or taper the form, things like that, okay, and also the percentage of this green area, the ratio, and so on. So those are the performances that can be evaluated during the LD 100. Then when we using the same model, okay, don't mistaken me, it's not different model, but it's the same model. When we say LD means the model become more detailed and detailed. Okay, we are still referring to the same model. So when we move on to LD 200, we can detail up the model with some approximate dimensions. We put in some main structures. Then from there, we start to design the building form, facade orientation, solar shading. Okay, we start to put in shading devices, openings. Okay, we put the windows, we put the void, the spaces, we have the layout, and also the main structure. So from there, we can evaluate the solar study, daylight, shading, natural ventilation, zoning, and so on. Then during this time, there is a high impact on the functional and performance of and the cost of the building. Okay, while with the minimum cost of design changes. That's why a lot of important design decision making should be made during that phase. While we move on to the design development phase, where we have more precise envelope. Okay, we know what are the materials, what are the glazing, what type of glass, is it tempered glass, laminated glass, okay, or tinted or low E glass, and so on. What kind of material? Okay, do you have insulation? What kind of spaces, structure, mechanical, electrical, and plumbing systems? Okay, what kind of aircon? Do you use any high energy efficient leaf, and so on? So during that time, we can evaluate the building energy performance, where we can also simulate the heat gain because we know what is the thermal properties of the building materials, including the OTTV, overall thermal transfer value, and the RETV, the lighting, predicted mean words, embodied carbon, operational carbon, and so on. Then during the tender and coordination phase, which is LD 350, where you have detailed specifications, you have the time 4D and the cost 5D beam, and we know who are the supplier, manufacturer, and so on. So from there, we can evaluate the energy, the cost analysis, value engineering, the phasing of the project, and also the green building ratings. Okay, usually that is the phase that the green building consultant will submit for green rating, for example, GBI, Green Re, or Green Mark. Okay, then LD 400 is the construction phase. That's where the model become more detailed with the actual construction sequence. 4D, we can even visualize the master work program in a 3D model. Okay, or we say 4D model. Okay, we can look into actual costs, logistic, coordination. How is the installation, transportation, where to put the tower crane, and so on. Okay, those are the sequence that we can evaluate. We can evaluate the supply chain. Okay, we can evaluate the supply chain, which is very important for us to have a timely delivery of the project. We look into the logistic, clash detection, waste management, green building rating, final evaluation. Okay, this during the final inspection. Okay, and during the construction phase, it contribute 10 to 15% of carbon emission throughout the life cycle of a building. We'll come to the as-built or the operational phase, which is LD 500 to 600. There's the as-built model. We have the occupancy data, maintenance, refurbishment, demolition. So we can look into the life cycle carbon emission of the building, where we can look into how to maintain the building, how to improve the sustainability of the building throughout different phases, the post-occupancy evaluation, the operational, energy, and also waste management. So basically, this chart sum up how BIM can support the green building design process and also evaluation process throughout the building life cycle. Okay, and of course, during the operation, that actually contribute 75 to 80% of carbon emission. But don't forget that 75 to 80% is actually has been decided back in your conceptual design and schematic design. Okay, because the design decision making that you make during the LD 100, 200 will actually influence what will happen during the operational phase. So we have to look at green building design or evaluation at the entire life cycle holistically. Okay, it's not only at one phase. And there are so many BIM applications that can support different design decision making and also performance evaluations throughout the project. Okay, here are some examples of BIM software or we call it tools that can be used by different parties. For example, architects usually use Revit, ArchiCAD, okay, or Vectorworks. But some like contractor usually they will use this Navisworks, okay, to simulate the 4D clash detection. While green building designer might use a Green Building Studio, Ecotech, and other software to simulate the performances. Right now, I want to focus on this 6D BIM, which is for the sustainability. Okay, remember we have 3D, 4D, 5D. 4D and 5D is more on the time and the cost. Okay, we will impact a lot during the construction phase. But now I want to look into 6D, which is the sustainability analysis, or sometimes we call it green BIM. Okay, is another term we call green BIM, which is the use of BIM to analyze and achieve green building design. We know the data in the BIM model. Remember the pyramid? Okay? A lot of time we only see the iceberg, tip of the iceberg, but below it there are so many data managements. So we can actually extract this data to do different kind of sustainability analysis or green building ratings. And based on the survey, you can see that most of the BIM practitioners, they use BIM for energy analysis, okay, up to 83% of them. And 60% of them use BIM for daylighting or solar analysis, and 53% use for building orientation analysis, massing and site analysis, and so on. And of course, this survey was based in US back in 2009. Then we look at, there are different kind of tools, software available in the market. I just give some example here because I'm not selling any software. I just show some example. For example, Autodesk Insight, okay, which is integrated in the Revit. We also have IES, Integrated Environmental Solution, Virtual Environments, which is also commonly used in the green building industry. Ecotech analysis, design builder, these are some of the examples of those simulation software. So how are we going to select what tools or what software to use for our projects? First thing, we have to look at what is the project stage and what are the tasks to perform. Then secondly, what are the available input data? Okay, and also what are the required simulation outputs? Because not every software can simulate everything. For example, if you use design builder, you cannot simulate the glare. While you use IS, you can simulate the glare, but there are also limitations. You cannot do the acoustic and so on. Okay, so you have to know what is the limitation of each software and what is your required output, and also your expertise or profession. Because some of the software like Energy Plus or DOE are without a graphical user interface, okay, where you have to have a very strong programming background in order to operate it. So you have to know what is your expertise to select the appropriate software. And this is a general workflow of this 6D BIM, where we have modeling in the modeling software, for example, Revit Architect, Bentley, and the setting. That's where we need to input all this data, like the project info, building type, occasion, project phase, create the rooms, the zones, and export the file. It could be exported to IFC. IFC stands for Industrial Foundation Classes. It can be exported to GBXML, which stands for Green Building Extendable Markup Language, or CAD. Okay, for green building, actually, most of the software are still commonly using these GBXML formats. Okay, of course, the data interoperability is a very important aspect that we want to make sure the data can be exported to the sustainability tools. For example, IES, Design Builder. Then some of these software also have a plugin to extract the data from one software to another software. And the type of assessment that can be done, including the thermal energy use, thermal analysis, CFD, comfort analysis, and also visual and shading, for example, solar, daylighting, illuminance, and so on. So different tools have different functionalities. It's very important for us to understand what is the required output, and we select the appropriate tools. Here's another example, which is the Green Building Studio. It's also by Autodesk that we can export the model through the GBXML file to do this green building evaluation, including this energy performance using Energy Plus. And this is a simple comparison of a few software that's commonly used in the market, I would say, like IESVE, Design Builder, GBS is Green Building Studio, and also Autodesk Insight 360. And we look at this comparison, you can see that some software have this function, some do not have, some is like partially. For instance, the graphical 3D results, okay, IES, Design Builder, and Insight 360 have that, but for GBS, there's no, okay, it's more on graph and data. And furthermore, if you look at the simple input review or simple input modification, some software are partially have and some do not have. Okay, and that's why we need to know what are the limitation of each of these software. Okay, but of course, I'm not going into very detail to compare one by one here because I'm not promoting any software here. Okay, but I would just want to show you that there are many available tools to support BIM for green building design and evaluations. Then now I want to give some example and some actual example of application of 6D BIM. For instance, this solar and thermal analysis. Okay, so with the available of weather data, we can download or we can create our own weather data file. Okay, which is very important because if you use the wrong weather data file, that means our results are not accurate. Okay, so with the weather data, and solar study can be conducted to analyze the indoor thermal comfort And most of these tools actually use weather data file from Energy Plus or the US Department of Energy. And for example, shadow casting, solar radiation, and heat gain can be simulated. This is an example of project where we did the BIM model of this high-rise commercial building. It's a 59-story commercial high-rise building in Johor Bahru. It's under construction now. We did the BIM model up to BP submission phase. Then we also use the model to do some solar analysis using Insight. Then we look at the exposure to the direct sunlight, how we put the shading, and how much you can reduce the solar heat gain. And currently the project is still under construction. And this is another example how we can use BIM model. And this one is using ISVE. It's a mosque building at Jalan Lonceng in JB, Malaysia. It has been completed. Then during the design phase, we use the model to do this shadow casting analysis to decide where to put the PV panels, the photovoltaic panels. So we simulate during the different design days, 21st March, June, September, December, in order to avoid the solar PV being shaded during the optimum hour. Optimum hours for PV is in the 10 in the morning until 4 in the afternoon. So we identify some area is shaded, so we recommend to the owner not to install the PV at the position. Okay, this is another example which is daylighting analysis. Okay, we know in the model, with the model we can export to different tools to do different kind of analysis, and daylighting is one of them. For example, we can simulate the illuminance level, the luxury level, daylight factor, luminance, UDI, which stands for useful daylight illuminance, and glare index. And some of this software, for example, ISVE and even the design builder, actually integrate electric lighting together with daylighting in order to study the potential energy saving. That means the result of this daylighting can be integrated with photo sensor so that the light can turn off when the lux level is sufficient. Okay, so the figure shows some of the example of daylight factor simulation and UDI simulation in some of the apartment building using Autodesk Insight and also using Design Builder. This is another example where we use the daylight simulation to decide where to put our skylight opening. When we have all the skylight available, then in the option 1, the lux level is too high. Then we reduce the number of skylights in order to achieve the optimum level in the daylight for visual comfort. And this is another application which is CFD, which stands for Computational Fluid Dynamics. It's used to study the ventilation and wind flow, which can simulate the wind velocity, meter per second, and also the air change rates. And CFD can also be used to simulate the temperature, airflow, in order to assess the predicted mean loads, PMV, for the indoor thermal comfort analysis, okay, which is about the human comfort, okay, the thermal comfort. These are some examples of the actual building that we have used to simulate. One on the left-hand side is the one that is indoor CFD analysis, while on the right-hand side is another apartment at campus which used for the macro analysis, where how we look at how the configuration of the building blocks affect the wind flow. And of course, 6D beam can be used for energy analysis as well, where we can include the heating load, heating, cooling. Of course, in Malaysia is more on cooling. Okay, electric lighting, occupancy load. Then we can integrate the daylighting, solar shading, all this to integrate with for the energy simulation. And it can also provide the evaluation on the green building ratings, for example, LEED or BREEAM. Okay, just now I've shown some example of application in some actual buildings. And right now I would like to show some research projects, okay, on BIM for sustainability. We try to use BIM to support the green building design, or we call it as a design decision support system for green building. Okay, we use BIM to evaluate and optimize the building performances throughout the different project phases, start from LD 100 all the way up to 500 or even 600. Okay. Not only that, we also explore the integration of computer algorithm to increase the level of automation so that we can fasten the design process and make a better decision during the design in order to achieve this integrated green building design process. So we look into the green building evaluation or the rating tools. Okay, what are the tools, for example, GBI, GreenRe, GreenMark, and so on, and how we can use BIM as the data, as the information that we have, and also use computational algorithm, some script to automate the process, to integrate this technology. As I mentioned at the beginning about convergence of technology, so we need to look into the possibility of integrating different technologies in order to achieve a better output. So these are examples of a green building assessment like GBI, GreenMark, BREEAM, and LEED. I don't want to go into detail, but what I want to say here is that different assessment methods, they have their different criteria. And one of the research that we look into is how to use genetic algorithm. This is a computational algorithm to optimize the design based on the data that we extract from BIM model for design decision making. And we focus on this overall thermal transfer value and also the building construction costs. And we have developed these tools. We call it BIMOS. We stand for BIM-based optimization for sustainability. Okay, where the users can actually export the data from the BIM model, import into this system, then they will produce this kind of OTTV and cost optimization graph for them to make the decision. For example, what are the wall and what are the types of windows they are going to choose for different orientation in order to optimize it. And apart from that, we also look into the visual programming language, for example, Autodesk Dynamo, to increase the level of data extraction and data management, how we can export the data automatically, and then to run some calculations in order to evaluate some of these green building performance criteria. And we know computational BIM is which means the integration of BIM and the visual programming language is very important to support the design decision making. It's more user friendly for designers to actually to evaluate while doing the design. So we further explore this integrate BIM, Revit, visual programming, which is Dynamo, with the algorithm, which is NSGA2, which stands for this non-dominant genetic algorithm with multi-objective optimization using MATLAB. So from there, we created these tools where we can automate the process of optimizing the design. For example, this is a case study building. I think many of us are familiar with it. In fact, I'm inside this building now. This is B11 in UTM. It's one of the block in our faculty. So we take this building model and we run the optimization script, and it's automatically replace the original model with the optimized design. For example, the facade here, you can see the original design, the OTTV was 48.83, and after optimized, it's become 25.57, and the investment cost also reduced. It's because of the choice of material, the window size, the type of the glazing, and so on. And we further explore with more complex building, like this is a case study building of office tower in TRX KL, where we use similar method to evaluate it. Okay, but we not only OTTV, but we also look into building energy intensity, and we also look into the material, like sustainable material, recycled material, and how we can calculate how the percentage, okay, of the use of sustainable materials in the building. And some other ongoing research that we look into the integration of green building, BIM, computational algorithm, that currently we are looking into the possibility to integrate this kind of evaluation process to increase the level of automation using computational algorithm, and to develop some kind of plug into the software. This is still ongoing research that we collaborate with Green RE, and this is how the output and how it can contribute to the stakeholders. Okay, I think I should conclude now. Okay, I've given an overview of how to use BIM to support the green building design throughout different phases of a project lifecycle. Okay, don't only look at one phase, okay, but every phases, including the construction, the design, construction, all the way up to operational. And we know green building design requires the team to analyze different parties involved and need to collaborate together. That's why a centralized database is very important. And the process of evaluating the performance or altering the design is currently is normally disjointed and time consuming. So that's why a BIM-based model can provide a higher level of automation for green building design decision making. And the integration of BIM, 6D BIM, and also computational algorithm can increase the automation of green building design and evaluation. So it's very important to integrate all these different technologies so that we can support a more integrated process in order to achieve a better project delivery, a more sustainable or green building. That's all from me. Okay, thank you for your attention.
All right. Thank you so much, Dr. Limietwa, for a very interesting presentation, I can say, even though it's quite technical, but I believe it's very important for the students. It's like an overview of what you should expect when you're working next, when you're working later. Okay. All right. So now we will go to a question and answer session. I will unmute. If you have any question, you can just press the button to speak, or you can also write in the chat box. Anyone?
I think I better start the ball rolling before anyone give any questions. And this question is actually for Prof. Sam from Sasi Creative School of Architecture. Okay, it is a very interesting talk, Prof. Sasi, when you talk about the current condition of the land estate, I think, in India, isn't it? And looking at that situation and scenario is that housing for students is actually in demand now in the Indian market. So how, if you're looking at the scenario in Malaysia now, the cost of housing is very expensive in Malaysia. So because there are so many factors, maybe because of the cost of land also is maybe play a major role and factors in the Malaysian context. So from the Indian perspective, or maybe from the side in India, what about the current conditions of housing or living standard in India in terms of the selling price of housing in India, especially for the medium income group? The availability of that, because you're saying that now is in demand is in terms of housing for students in terms of the market value. So what about in terms of the housing scheme for medium income or for the upper higher income or the low income group in India? What is the situation? Maybe it's nice to hear the views from a different perspective compared to Malaysia.
Sure, Prof. Alice. That's a valid question. I would say there are flip sides to that as well. If we consider the housing market for upper middle class or the middle class, and it again depends on the developer's perspective, and also the way in which people want their amenities to be. Now, it also depends on the location. If I want to buy a 3-bedroom apartment in Bangalore, I might have to shell, say, I think I'll tell in Indian rupees of fine. Should be 80 lakhs to 100 lakhs. All right, 1 crore. If I have to get a same 3-bedroom apartment in where I reside right now, it will be costing me around 50 lakhs or something. And so it depends on the locality. It depends on whether the particular place is closer to the central business district or something. And more importantly, I would say, I mean, if we talk about the affordability point of view, yes, it is affordable to, I would say, at least say 25 to 30% of the population, I mean, who are predominantly in the banking sector or the pharmaceutical sector and the doctors. We can't expect the same to happen to a lot of other people who might not have kind of a streamlined income. And more importantly, there are certain scenarios where because of credit score, people might not be in a position to get the loans that they want. And that actually is another thing. But talking about housing schemes, the government has come up with a lot of schemes. The recent one that is happening is the Prime Minister Awas Yojana, which is the Prime Minister Housing Scheme. It actually caters to the lower income group, and it's like participatory development. The homeowner has to give 15% or something, and the rest will be shelled out by the government. And that is happening one side. But again, as you mentioned in the research proposal that was sent, there's a huge deficit as far as supply and demand is concerned, even today, even after so many years of independence, or what we call it as.
Okay, all right. Thank you, Prof. Sam, and also thank you, Dr. Alice, for the question. So next, anyone have a question? Perhaps from students, either from Sasi or from UTM? Anyone?
Okay, since no one asked you a question, I think I have a question to ask to Dr. Lim. Okay, what is the future for BIM actually in the Malaysian market? I can see that when you presented in terms of your technical point of view, I know BIM there's a lot of potentiality into it, which means that it can venture into so many things and help the building industry. So let's say 20 years down the road, or maybe 20 years down the road, or maybe 20 to 30 years down the road, what is the future for BIM? Or can BIM sustain itself, or can BIM expand to a different areas or different aspects? Perhaps Dr. Lim, since you're also an expert in BIM, I would like to know what is the future planning actually for BIM in terms of them to venture into a different things or different field, or maybe can expand into something new in terms of technology.
Okay, thank you, Dr. Alice, for the questions. Yeah, it's a very good question. What is the future of BIM? Actually, many people started to discuss, then some even come up with the term of instead of building information, they say it's building knowledge, modeling. Okay. There could be different terms coming in, but I think the terminology is not the main point. But BIM is definitely something that you change the building industry, or the AEC, we call it architectural engineering construction industry, the way of working. And because it's about the process, the working culture, and also the collaboration. So it's more than just the tools or the software itself. Okay. So we can see that in Malaysia currently, most of the market, especially in central region, okay, that means KL, Selangor, actually they are more ahead. Okay. If based on the survey by CIDB, is saying that more than 70% already adopted BIM. But the question is, what level of BIM? BIM can be level 0, level 1. Level 0, of course, not considered, okay, but level 1 or level 2. So currently, actually, a lot of practitioners are still actually up to level 1, which use BIM for modeling, to create visualization, and also produce drawings. But a lot of people still haven't seen the full application of BIM when we come to level 2, level 3. And those are the potential where we can apply BIM throughout the whole life cycle of a building project. And so we can see a lot of research are still ongoing. There are still a lot of gaps there. When we say 60, 70, some people started to say 80. They say 80 is for safety. Okay, some will come out, maybe tomorrow someone will say 9D. So sometimes we say there's infinity D. Because the application is still so many possibility. That's why still many people are exploring. But BIM is not confined within one tools or two tools, but BIM is actually the whole technology. If you look at other industry, for example, in the manufacturing, if you look at the aerodynamic, they do the airplane, actually they have already adopted so-called BIM, but there's not called BIM, okay? But this kind of information modeling, long time ago. And even one of our very famous architect, like Frank Gehry actually adopted BIM much more earlier because he adopted CATIA software. CATIA software is actually a software to use to do aircraft, Boeing aircraft. They use CATIA. But Frank Gehry adopted CATIA into building industry in the design project. That's why he managed to do this kind of different form. His design, okay, is very outstanding. The form so organic. Why they can manufacture it piece by piece is different dimension, totally different. It's because of the software, because of the technology. So you can see with BIM, actually we support the building industry to move forward to explore more different design alternatives and new technology. And which is very important to support the building performance and for the sustainability. So I would say in the future, there are still a lot of rooms for the developments. Okay, there are still a lot of ongoing research worldwide. Okay, and in Malaysia, we are actually still at the beginning. Still a lot of rooms to improve. Yeah, that's my opinion.
Okay, thank you so much, Dr. Lim. Just to share that I think there's a lot of authorities in Malaysia currently that are trying to implement the submission using BIM and so on. So if you are a check or you are a consultation firm in Malaysia, so lucky or not, you have to be be with the technology. Make sure that you are with it, and then if not, it's quite hard to submit for any application. Okay, all right. Then is there any question? Additional question from students? Anyone? No? Okay. Then before I post the uh, attendance form, can we have a photo session? So I hope that everyone who participates in today's event, please turn on your camera. Dr. Aiman, are you there? Can you help me to snap the photo? I'm afraid that I might lost some of it.
Yeah, can I say hello to Prof. Gayatri? Hello, Prof. Gayatri. How are you?
Hi,
Hi,
Prof.
Dr. Alice. I'm fine. Thank you.
Yes, yes. Nice to see you.
Yeah, I've heard about you from Sam. I guess we will meet later.
Yeah, yeah. We will meet on the 15th. Nice
Yeah.
to see you. Nice to see you ahead of time. And I can see also some of your few students from Sasi is also here.
Yes, so very few have joined then today. Yeah,
Yeah, yeah. That's good. That's good. So we can actually keep up the spirit between both schools actually.
surely. Thank you very much.
Okay.
How should I? Okay, okay. Still adding those with the video with the camera on. Okay. Get ready. On the count of three. 1, 2, 3. Okay, I will go to the next page. One, two, three. Oops, again. Okay. Another page. Okay, done. Okay. All right. We have done with the presentation by both speakers. So thank you to both speakers for all the presentations. It's such a great presentation. And so it was a great pleasure to have both of you with us in the our international webinar series #1. We have a lot more coming up. And then which is this webinar series actually organized by Program of Architecture and also in collaboration with Sasi Creative School of Architecture, India. So post the form now in the chat box. Okay, so you have about 12 minutes to fill in the form before it's going to expire at 4:15 Malaysian time. Please make sure when you fill in the form, put in your full name in capital letter and also make sure you put in a correct email address because the e-cert will be auto-generate and sent directly to the email that you filled in the form given. Okay?
All right, maybe
So,
Architecture, while
yes,
waiting for them to fill in the form,
yeah,
we cannot close up the room yet. So
yes,
maybe if there is any question adding on that any students or any participant or audience would like to ask Prof. Sam and also Dr. Lim Yek Wah, the other two
yeah,
experts, one on real estate, another one is on BIM for green building design, especially for students who are going to use BIM for this semester. Please post up your question because you won't meet up these two experts again. All right, you meet
yeah,
in the faculty but not in the same room, in the same forum actually.
yeah.
So
Perhaps
anyone?
not a question or any opinion or you want to add up?
Yeah, I think I saw there's an audience by the name of Dr. Champa. I'm not so sure. Um, is this an academic staff or a student? So it is quite interesting because it's a very unique name, Dr. Champa.
Yeah. Dr. Champa, can you turn on, can you say
Yeah, good
something?
afternoon. Good afternoon.
Good afternoon.
Yes,
Yeah,
Dr.
yes, I'm a faculty, I'm a professor and dean at a School of Architecture in India,
Oh, that's
myself to
good.
be more specific. And Gayatri and Sam have been my colleagues earlier. Okay. And yes, I heard the entire session, all the sessions, and they were really informative and very good. I'm sure even the students who are listening to it has a lot to take and learn from it. Okay. And I really congratulate both the institutes for organizing this. And I think more session on different kind of topics should follow this. Okay. So
Yep,
thank you all so much for organizing it. Hmm?
yep.
Yeah.
Thank you so much, Dr. Champa. Sorry I pick up your name because your name sounds so unique in the screen from all of the names.
Yeah,
It stands out.
it's a flower. I mean, champa means flower.
Oh,
Ah, okay,
I
that's nice.
see. Okay.
It's a Sanskrit language,
Yeah,
is it? By
that is right.
Sanskrit word.
Yes,
Yes,
correct.
wonderful, wonderful. I hope to
Yeah,
see you again soon on the 15th
surely.
for our
Yeah,
next webinar
surely.
with Sasi.
Yeah,
Wonderful.
yes.
Yeah, I also
Okay.
saw seeing in the names also Ajis George. Okay, Ajish. I'm not so sure. I think Ajish also from Sasi. Is it? Is it a student or is it an academician? Ajish.
Yes, hello.
Yes. Hello,
Uh,
Ajish. Yes.
yes, I am actually a faculty in Sasi Creative School of Architecture.
Yeah. Good. So you are also from Sasi, academician from Sasi, right?
Yes, ma'am.
Okay, that's wonderful. That's wonderful. Maybe perhaps Prof. Sam, after this you can introduce the whole team that you have to the faculty members.
Yeah, because you can't
Uh,
really recognize everyone with the name. Just okay.
I guess so. So you met Gayatri is here. She's the director.
Yeah,
Ajit, he just spoke to you. And there was Nivedita, who will be the next speaker, webinar 2, who will be talking about contextual in terms of Tamil Nadu, right? And, history of architecture.
Yep.
I guess that's it. I think, I mean, there was another one who just left. Her name is Anbu Chelvi. She is an associate professor here with Sasi Creative School of Architecture. And I guess that's it. And very fortunate, I mean, they have mid-review today, all the students. So that was one of the reasons, why they were not able to be a part of it today. But we hope that they'll be very much a part of it over the next couple of webinars, and also, what we are going to do in the years or months to come.
Yep. Okay. Wonderful. Wonderful. So it is good. It's good to get to know you, and maybe we can have a meeting soon with all the academic staff from Sasi, right, from Sam. Yeah.
Okay.
Okay.
Yeah, I think it's not fair. It's just one side. So perhaps we have a few of our colleagues over here. Architect Samsia. We have Architect Samsia. Architect Samsia, want to say something?
Hi, I thought I can be excused.
Okay.
Okay. Actually, not much. It's just that it's interesting that we are sharing on the beam, yeah. Because basically, I do agree with Dr. Lim, yeah, because beam is not just a tool. It's perhaps 5 years or 10 years down the road. Basically, it's a requirement, yeah, especially in Malaysia, whereby for now there's 3 local authorities that are actually already implemented, whereby if you want to do the submission, you have to submit, you have to use beam, yeah. And then and that will be, as a precedent, or that will be like a pilot project. So in perhaps 5 to 10 years, if you don't use beam, perhaps you won't be able to participate in tender as well. Yeah, because all the big institution actually requires, it's part of their requirements, especially I think JKR, yeah, and big developers like Sime Darby and so on. Yeah, if basically they require BIM. Yeah. So basically, whether you like it or not, you have to utilize, you have to know, you have to actually implement it in your office. And it's actually a big thing for practices, yeah, because of course it's basically just like those days where you want to migrate from manual drawings to AutoCAD, yeah. Some people are reluctant, but basically the same case here. If you are reluctant, you'll be left out. Yeah. So I think that's it.
Yeah, like take it or leave it. Okay, so next we also have Dr. Roshida. Dr. Roshida, would you like to say
I'm
something?
here. Sorry, I cannot open my camera. Just take off my scarf.
Okay.
I am attending 2 sessions at the moment, actually.
Oh,
Uh,
okay.
but I think it's a good session, yeah. Having this collaboration between the having this talk by Dr. Sam, Prof. Sam, and also by Dr. Lim Yewa on beams, yeah, which is, I think, is a good start for this semester, and I hope that all the students can open your eyes in all the possibilities that you can do, especially in applying all the technologies in your design. That's all from me. Thank you, Architecture.
Okay, thank you so much, Dr. Rashida. So we also have Dr. Khairul over here. Dr. Khairul? Dr. Khairul, would you like to say something? Just a little of update. We have about 98 responses received at the moment. So I think most of the students has filled in the form. So for the webinar series, it's considered ends already. Okay, but then we would like to remain. I mean, I would like to call for all the UTM staff, academicians to remain for a quick, what we call as a sparking session with those from Sasi. Okay. So next, I would like to call Dr. PC. Are you there? Dr. PC? I saw his name just now. Okay, maybe he's doing something else. All right, but perhaps Dr. Faizal. Dr. Faizal?
Yes, I'm here.
Okay, would you like to introduce yourself?
Hi, Sam.
Hi, Professor. How are you?
I'm good. I'm good. Well, I think this session is very good. Yeah, and then yeah, as like other people said, I hope that this session can be, how to say, can get lots of benefits. Yeah, and from each other and learn something from each other. Yeah, and then it's a good thing. It's a good sharing knowledge session from both parties. Yeah, so yeah, looking forward for to see more. Yeah, more great presentation. Yeah, and sharing knowledge from both institution. Yeah, that's all from me. Back to you.
All right. Okay, thank you, Dr. Faizal. So anyone else I left? Perhaps Mr. Azari? Are you there? Mr. Azari? I think it's not, he is in this room, but probably doing something else also at the same time. It's okay, never mind. So I think most of the participants has already filled in the form, which means it's the end of these webinar sessions. Okay, so I would like to thank everyone for your time, for attending and listening to this webinar series, and we hope that this fruitful session has benefited you, every one of you. And don't not to forget, we are having the next webinar series in mid of November, I believe, right? At least, am I right?
It's November 15th, yes.
Yeah. Okay.
It's on the 15th. Yeah.
Yeah, on 15th, mid of November. So make sure you attend that as well. Okay, so I think that's all for me. That's all for the session today. Thank you everyone. Thank you so much everyone for attending.
Okay.
Thank you.
Thank you so much. Thank you,
Right.
Sam. See you
Thank you.
again.
Bye, everyone.
Thank you so much from Gayatri. Okay, bye
Thanks,
bye.